Hi, today we learn about Fourier series and Fourier transform concepts and learn the properties of Fourier series. So first of all, we'll get into the Fourier series. In mathematics, a Fourier series is a periodic function composed of harmonically related sinusoids combined by a weighted summation. With appropriate weights, one cycle of the summation can be made to approximate an arbitrary function in that interval. As such, the summation is a synthesis of another function. So the Fourier series has many such applications in electrical engineering, vibration analysis, acoustics, optics, signal processing, image processing, quantum mechanics, econometrics, thin-walled shells theory, etc. So we can get into the Fourier transform now. We can say in mathematics, a Fourier transform is a mathematical transform that decomposes a function into its constituent frequencies. Fourier transform of a function of time is a complex valued function of time frequency, whose magnitude represents the amount of that frequency present in the original function and whose argument is the phase offset of basic sinusoid in that frequency. Fourier transform refers to both frequency domain representation and the mathematical operation that associates that frequency domain representation to a function of time. Okay, now you'll see a slideshow of Fourier series and Fourier transform. We can get clear about them. So first of all, we see a signal S6 of x. Then we can get the Fourier, how we'll get Fourier series. We demonstrated that. So it's the Fourier transform of this signal. Okay, now we will get into the properties of Fourier series. Here the linearity property, if f of x, if x of t converts to f of fxn, then the linearity property states that. So the time shifting property, here we can say x of t minus t naught. This is a time shifting. We can clearly see here. So after Fourier series, we can get e to the power minus jn omega naught t naught fxn. So here the frequency shifting property, we can see here the frequency shifting property and the time scaling property. This time scaling property changes frequency components from omega naught to a omega naught. So time reversal property, here we can see here this is a minus sign x of minus t. So here will be also a minus sign. This is the time reversal property. And the differentiation and integration properties are like this. It will after differentiating x of t, when we will get the Fourier series coefficient, it will be jn omega naught into fxn. And the integration property, this term will be divided here. Okay, this term in the differentiation property, this term is multiplied with fxn, and this term will in the integration property, this term will divided. Okay, now multiplication and convolution properties. Here we can see that the multiplication converts to convolution, and the convolution property, here we can see the convolution converts to multiplication. So these are the properties of Fourier series. Thank you.